Hello students, we are still on graphs of linear functions, and today firstly we are going to talk about midpoint. So let's say for example you are given a Cartesian plane and you are given an equation of a graph and you are given 2 points. This is point A, this is point B, and you are asked to find the midpoint M, the coordinates of the midpoint between A and B. You have told to find the coordinates of the midpoint between A and B. So in order to find them, we use the formula that is given on the board, where coordinate for x plus coordinate for x2 are divided by 2, are added then divided by 2, the same for the y coordinate. So let's do an example so that it becomes a little bit clearer. Find the midpoint of coordinates 2, 3, and 6, 7. So we use the formula midpoint. It's given by 2. Midpoint is given by x1 plus x2 over 2. Put a semicolon here. Y1 plus y2 over 2. So we substitute into our formula. X1 is 2 plus 6 over 2. So that's going to be 3 plus 7 over 2. So our answer here is going to be 6 plus 2, that's 6 and 8, 8, 4 divided by 2. Put our semicolon, 7, 8, 9, 10 divided by 2, it's 5. So this is going to be the midpoint of those two coordinates. So let's move on and talk about parallel lines. So parallel lines are lines that have the same distance between them. They have the same distance between them. So if you measure here, it's the same distance, here is the same distance, here is the same distance. So that's what we call parallel lines. And one defining feature about parallel lines is that they have the same gradient. They have the same gradient. So the gradient of a line parallel to A is the same as the gradient of B. So A will have the same gradient as B if they are parallel. So let's do an example. Find the equation of a line parallel to Y. Find the equation of a line parallel to Y is equals to 2x plus 1. So, and passing through point 0.04. So you're given a point and you're given a line parallel to the one that you're looking for. What do we know about parallel lines? The gradients are the same. So we already have M, which we can take to the line parallel to it, which is 2. So we write our equation for a line y minus y1 is equals to M x minus x1. So we already have a point. So we say y minus, that's 4, is equals to M. Our M is 2. And x minus 0. So we are going to have y is equal to 2x plus 4. So this is a line parallel to this line. So that's how we use parallel lines to find the equation of a line. Let's move to perpendicular lines. Perpendicular lines. So in perpendicular lines, these are lines that meet and they form an angle 90 degrees. These are what we call perpendicular lines, and their defining feature is if you multiply the gradients of perpendicular line, they give you -1. So let's do an example to prove this. Find the equation of a line perpendicular to y is equals to 4x plus 1 and passing through the point 4, 6. So line y is equals to 4x plus 1 and passing through the point 4, 6. So the first thing that we do is let's find the gradient of this line that we are looking for. So the gradient we take here, this is the gradient m1. If we multiply it with the gradient that we are looking for, m2, we are going to get minus 1. So m1 we have it 4 multiplied by m2 is equals to minus 1. So m2 is equals to minus 4 minus 1 over 4. So this is the gradient of the line that we are calculating. We now have the gradient and a point. We can go ahead and use our equation. So our gradient here becomes, that's our gradient. So we are going to have our equation x y minus y1 is equals to m x minus x1. So we say y minus y1, which is 6, is equals to our gradient x minus, and we input our x1, which is 4. So here we are going to have y minus 6 is equals to minus 1 over 4x. Here, since there is a minus, we are going to have plus, and the 4s are going to cancel out. So we are going to have y is equals to minus 1 over 4x. The 6 is going to go to that side. So plus 6, so it's going to be plus 7. So this is going to be the equation. It's going to be y is equals to 4x plus 7. So we can use the defining features of parallel lines and perpendicular lines in order